So we're looking at a virtual machine here. This is not a live USB. This is a virtual machine that is in a Ubuntu host system. And I want to cover what Alibre looks like and how Alibre performs in a virtual machine. I also want to cover making a mouse. I had a question about how to make a mouse in Alibre because FreeCAD, I used some surfacing tools to make a mouse, or several mice, and I was asked, well, can you do it in Alibre because Alibre doesn't really do surfacing in the same way? And the answer, I think, is yes, right? I was able to make a mouse without too much issue. That seems to have, the curvy surfaces that any of my other mice have. So I'd like to say that yes, Alibre can do it without very much drama. So let's get started in making one. Let's open up a new part. And let's start by activating a sketch. In fact, I should go to my view and make sure that my planes and sketches are on. We'll create a sketch on our top plane. And from the sketch menu, I'll make an arc. Which is not too shabby. Now, we'll come over here and make a dimension. Give this a radius of 2.5. In fact, let me try a tangent arc, right? I'm going to try to connect some tangent arcs in here. So there's one tangent arc. And there's another tangent arc. So I'll grab my equals and make sure that all of these are equal radius at 2.5. I'm going to grab a horizontal, and I'll make sure that these 2 points and these 2 points are horizontal. Now, move my screen up with the center mouse button. We'll go with another arc. I'll add tangent relations and make sure that these are tangent. Good. I'm probably doing something that's not necessary, but let's make sure that this arc center is vertical to our origin. Looks like it is. And then equal to the other arc sizes so that every arc has a radius of 2.5. We'll go with a vertical dimension from the origin to our second arc's center. Make that 4 inches. So that looks kind of like the base of a mouse, at least one of those older 90s ones. We'll deactivate. And I'll try to grab this plane and make another plane offset 1.5 inches. And I can also, I want to do another plane. I can also check that multiple planes box too. Okay, from the view cube I'll choose an isometric view, and choosing this middle plane here, let's activate a 2D sketch. I want to make another arc. We'll go with vertical. We'll draw a line. And we'll go tangent. Okay. We'll make sure that we are horizontal in these points and horizontal over here. Now what if we want to be a little bit more fancy and work with an ellipse? Let's do a quick exercise on ellipses. Let's also make sure that these lines are equal, and that way we can maintain a good symmetry. There we are. And before I get out my ellipse, let's just give this a dimension here of, how about 2.45. And a vertical dimension of the same 4 inches. All right. Let's make an ellipse. This is probably redundant. I want to make sure that we're perfectly vertical on that point. That looks like that did make a difference. We'll give this point a vertical height. And we'll go with 2.25. And then we'll give this side point a different dimension so that we can have somewhat of an ellipse eccentricity. 2, right? So we're elliptical in the front now. So I've got my lines that are overlapping a little bit. Let's trim. I can trim the top part of my geometry off here, and then I can add relations as we need. First things first, let's add in a coincident relation between these points, and then let's add a tangent. Looks like we're doing about the same on the other side. So we've destroyed a few relations on the way. We still have our 2 and 2.25 inch dimensions over there, which is very encouraging. So then we just have to ask ourselves, what are we missing? I'm thinking I can just take this point here and this point, and we'll make them coincident. Yep, and that goes right back to the dimension that we set. Same with this, right? We'll take the edge of our ellipse here and this point, and we'll make them coincident. Oh, and it looks like we'll add a vertical dimension from here to the origin. And there we are, we're fully defined. So I think I added 1 or 2 unnecessary constraints or relations there, but we have that middle profile. Hooray! So working with ellipses can be a little bit tricky, but it's just like any other program, right? It works. Let's go with this plane. 2D sketch. I'm going to go with another arc. We'll make this another simple profile. Alright, so I got these two arcs. I'm going to make sure that their endpoints are horizontal. So we're going to go with 3, and we'll give this a radius of, well, maybe instead of radius I'll define it with distance between endpoints. We're going to make that 5. There we go. From endpoint to endpoint. We're going to go with, say, a distance of 4. We're going to make sure that our arcs have a center that's vertical to the origin here. And now I'm going to make a line and finish up the top profile of the mouse by enclosing it. Let's go with tangents. So tangent there, tangent here, and we should be almost fully defined. Yep, looks like we just probably need a vertical. Well, we're fully defined, not in the way that I want it to be. That happens sometimes, so we'll just drag this point up. That should have it snap to the right position when it's fully defined. Right there. So we'll deactivate that. I think we're well on our way here. Let's go back to our top kind of diagonal view and take a look at a loft that we can make. So we'll go with the loft, we'll add this profile, and this profile. For sketch 3, we'll make a tangent so that it will, or tangent, normal to the next profile. And so from the right view, we're going to uncheck minimize curvature, and there you can see we become tangent a little bit faster. So that should give us kind of more of an interesting profile. I'm going to say OK to that. And coming back to this view, we want to make a sketch that will define the top of the mouse. So in fact, let's go to the YZ plane, activate a sketch. And I think we can do this with a tight 2 arcs. So I'm going to draw an arc here. I'm going to say a horizontal dimension to the origin. And let's go with 3 inches. We'll do a vertical dimension. We'll define this point, say 1/2 inch. We'll give this a radius of 14 inches. Let's go with an arc that is vertical to its center point so that it ends on horizontal. And you know what? I want to reposition this, so I'm just going to get rid of my 14-inch dimension here. And let's position this a bit more like that. That's better. Still ends with with that little vertical constraint, so I'll re-add my dimension here at 14. Let's use another arc. And then I'll add both a vertical constraint from its end to its center point, and we'll add in a horizontal. Right, and so now it's almost like a perfect 90 degrees. We'll give this a dimension from the origin to its endpoint. We'll go with something like 6.68. And then I'll add another horizontal to the origin to define where this thing starts out. Okay, so I dimensioned the midpoint of that arc. I needed to dimension the endpoint here. 6.68. Much better. We'll deactivate the sketch. And that's just telling us that we have not closed our sketch profile, but we've done that on purpose. I'm going to select my top plane here, and we'll activate a sketch. Okay, apparently it selected the axis, so select our plane, and now we're sketching. I want to make sure that I start on the endpoint that I wish to start with, and there you can see our endpoint coming out. So what we'll do is we'll project our endpoint to the sketch. We'll do so with the reference figure. Right, we can select this line. And we'll maintain association. So we've got our nice little endpoint right there that we know where the arc ends. I'm going to grab another arc of my own. I'll reset my view. And I'll grab a horizontal to make sure that the ends of my arc are horizontal with each other. And I'll use a vertical. We'll grab our arc center and make sure it's vertical to the origin. Grab a dimension and make sure that the arc is going to have a radius, and I'm not sure what the best radius for the profile of our mouse top to have is. Let's go with something like 5 inches, and then from edge to edge I'll say 7 inches wide. We'll go with a coincident relation. There it is. Now align. And we'll go with a vertical here. And an arbitrary dimension to finish this off. Great, we're going to deactivate the sketch. Now we can choose a subtractive sweep. This will be our profile. Then I'll select our path. And there's a mouse for us. So let's add a few details that could be useful and fun. First thing, I'm going to choose a fillet. 1/2 inch looks fine. I'm going to select the two top faces to get more of a smooth organic geometry going around the top. I'll close that. Normally you save your fillets till the very end. I feel like this fillet could be affecting other features, and so I want to make sure that I add the features with the fillet so that I can know that everything will work with the final geometry. Let's create a sketch on the YZ plane. We'll go with a circle. We're going to say dimension from the center to the origin at 3 inches. And give this a height. 3 inches, I should probably say 1.5. Even smaller. All right, we're going to add a nice little scrolly wheel on there. And then let's go with 1.5 here, right? So that could be a scroll wheel. Before I extrude that, I also want to hollow this out. And when I make this hollow, I want to do it before I add more features so that it will shell to a consistent thickness, right? I'm not trying to make an actual mouse with all of its individual components, just the impression of a mouse for the purposes of this video. So, shell, maybe 1/8 inch, 0.125. And it looks like my shell's broken. I don't know if I ended up not selecting this face. Looks like I had that face selected, so maybe 0.125 is too thick. Let's try 0.1. Nope. Wow, well, 0.05 works. A bit thin, but not too bad if you consider, you know, the actual thickness of a mouse. Maybe 0.075. Let's see if that works. Yeah, a bit better. We'll take our other sketch here. We'll extrude it to make the scrolling wheel, and that will be mid-plane, I think. Go to a depth of something like 0.25. Fantastic. Now, since we're making the impression of a mouse, you know, you'd probably have some assembly in here that reads the scrolls of the wheel or something. But if we just want to get rid of this, I think a quick and easy tip for someone who's using Atom, if you don't want to get into direct editing with the Pro license that Alibre offers, I can choose this bottom face, create a sketch on it, and you can, oh, I accidentally deleted my sketch. What do you know? You can and should get more detailed than what I'm about to do, but just to demonstrate the technique of doing this, I'll just draw a box around what I wish to get rid of on the other side. We'll deactivate and we'll choose extrude. We're going to say to geometry. And I can choose this face as geometry. And it makes that wheel disappear like a magic trick. So that's a great way to get rid of a feature on a NURB surface if you ever have to do that. Okay. Maybe I'll scroll in and fill up my mouse wheel. And then I think for the purposes of what I'm hoping to accomplish, I think we'll be done. We'll go with a 0.125. So how does Alibre work in a virtual environment? I think it's a little bit more rough on the views, and it takes a little longer for the things that you do to show up, like when drawing arcs, but I don't think I have any real concerns with using Alibre Atom on a virtual machine if I have to. I think it's a good solution, and it works well enough that we can make this whole model in a virtualized environment, and we haven't had any performance issues other than just needing to wait for a few things. So I hope this was helpful. I think this will hopefully be enough information to determine for your needs if Alibre runs okay on a virtual machine. Hope this was helpful. If it was, please subscribe, and I'll see you in the next one.